Doing some quantum physics and before moving into the section on light. The revision section is on ray optics, where you will revisit Snell-Descartes law. The first section on quantum physics and applications first discusses the case of the hydrogen atom using the semi-classical approximation of the many-path formulation, and we will with that recognize the spectrum of the hydrogen atom as measured experimentally. We will then look at the case of the harmonic oscillator. However, here we will find that the semi-classical approximation is not valid, and we need an exact treatment of quantum mechanics. In principle, we can do that with a many-path formulation without the semi-classical approximation, but that's usually too complicated, and a better way is to start from the Schrödinger wave equation. So in this section, we will show the equivalence between many-path formulation and Schrödinger equation. However, this is a relatively advanced section, which I encourage you to look at, in particular if you are planning to do some more physics course next year. Nevertheless, it's not going to be accessible. So if you find it a bit daunting, feel free to skip it. The next section on light remains at first in the framework of quantum mechanics, because we will discuss the nature of light. Is it a particle or is it a wave? Or is it both? And for once, we will use a historical approach with the black body radiation and Einstein's discovery of the photon, which started quantum mechanics. So we will then move to the what happened when we take the classical limit of the many-path formulation with photons. We will find the Fermat's principle of least time, from which we can get ray optics, and in particular the Snell-Descartes law, and with all the applications of ray optics which you are aware of. We will then discuss the case. So what happened when we want to characterize the speed of the wave in a medium? So when we are talking of sound, for instance, the sound is propagating through the air at a given velocity. But this velocity depends on the motion of the observer. If the observer is also moving through the air, then he or she will measure a different speed for the wave in the medium. So by analogy with the air, people were thinking that there was an ether in which light was propagating. Then Michelson and Morley designed an experiment to measure the motion of the ether around us due to the motion of the Earth around the Sun. And they were expecting to see a modulation between summer, winter, etc. And they didn't see any, and the conclusions was naturally that there was no such ether at all. And that's what partly led to the discovery of relativity.